I'm going to take this one. Okay, I'm going to take this particular spreadsheet now. This is an Excel spreadsheet. Okay, it's got a new set of values. I put some other stuff in here. But it's got 21 subjects, right? The variable is called X, whatever that represents. Could be blood pressure, or I don't know, actually this could be ages, it could be any number of things. I want to work with that. We just did this exercise with Excel. I want to work with that with some more capable software for statistics, something that'll give me answers a little bit quicker. Now, there's two things I could do here. One is I could say to myself, this is right now saved as an Excel file on my computer. I can also save it. I can also say File, Save As, and I can save this in other formats. If I click on this, I can save this as a comma delimited file. I'm going to do that for now. I'm not sure where I am. I'm going to put it on the desktop, so save. And it's also there on my desktop. It's warning me that there may be features in here like formatting and stuff like that, bold, centering, that I'm going to lose. I don't care about that. You have to keep the format with to prevent it, click no. Okay, save. I guess I have to say yes. Okay. So let me get this out of the way now. Now I want to work with that data in another program. I'm going to open up SPSS for starters. If I can find it. Let's see if it's on the desktop. Nope, that's a data set. Okay. Okay, it's under the menu there. If you can't find it on your computer, find it in the menu. Uh-oh, I just opened the wrong thing. Don't hit the computer thing. That's a thing that allows you to run it. With faculty, run it off campus, I think, or something like that. I don't want the computer license. I want that. Just statistics. In about 20 minutes, it'll open up. What could it be doing? At 7 billion cycles a second, sometimes you got to ask yourself, what could it possibly be doing? That's IBM and Microsoft. Put two big companies together, that's what happens. Okay, so now this is a convenient startup menu where you can use this menu to conveniently find files that you've been working on, or where data is stored and stuff like that. It's a pain in the butt. I always turn it off and just use File. File and Open. Okay. Open Data. We're going to open a data file. I'm going to go, right now we're in Documents, so I'm going to go up to Desktop. If you're not already there, you'd want to go up to Desktop also. That's probably where if you downloaded this from Blackberry, you probably stored it on your desktop. That's probably the only place you can put it on your computer is on the desktop. Okay, so now I'm on desktop. Now, let's see where that Excel file is that I left on the desktop. Might have been in, maybe it was in this session 2. I don't see it there. I only see one file. I know that there were 6 files in there. Why do I not see the other files? Right? Well, SPSS right now is only looking for files of type SAV, native SPSS files. That's why it doesn't see them. I could click down here and tell it to look for Excel files. And now I see all the Excel files that are in that folder, or in that folder. If I wanted to, I could just scroll all the way down, eventually get to all files, and I'll see all the files that are on there. Okay, so I just want to look at the Excel files. Okay, so now you notice there are a lot of file types there. SPSS will import many different file types. Okay, so now the one we were looking at was, I think, number 3. Okay, I'm going to click on there, and I'm going to say Open. Now, what it should do in a moment, hopefully, is going to open. It's going to say, you know, I see data between A1 and D26. Well, A1 to D26, the stuff in column C and D was detritus. It was other stuff that I had put in there, right? Not anything that I was going to use. It was really only I wanted an A1 that I was interested in, right? So I can put in the range that I want to work with. I think it's A1. Let me see, colon. And something's going on behind me there, eh? I think it was A22. And I'm going to hit say, okay, open it. I'm importing an Excel file. I'll do it again if you guys missed it. What? The CSV file I saved because there's another reason for that. We're going to use that if you want to work in R. You're going to want a CSV file.
No, but I mean like,
huh?
But I mean like when we were saving it.
Yeah.
Were we supposed to click yes or no in that window?
Yeah, you only get to say yes. If you say no, it won't let you do anything. That's really a warning that you're going to lose the formatting information.
So when I opened up the CSV file in SPSS,
yeah,
I got like a weird.
Yeah, there's a lot of detritus in there besides the raw data. I'll have to take a look at it. But let's go through this, and then we'll go back and take a look at the CSV file.
Okay.
Okay? I guess you're working on it already. Is that what's happening back there?
We went to open it. None of us should open it the way you did, because we didn't have it saved as Excel anymore.
Oh, you overrode it?
Yeah, we overrode it to save.
You were even able to do that and just give it the CSV file?
Yeah, the downloads are not saved.
Oh, they're not saved? Oh, okay. Well, download it again. It's still on Blackboard. You can't change it on Blackboard. We fixed it so you can't change any of that stuff. Okay. I'm going to give you a minute to catch up then. Yes. Yeah, Excel will allow you to import CSV files, Excel files, DBase files, Silk files, all sorts of different formats.
We're opening an SPSS.
I suggest right now I'm opening it as an Excel file.
Oh, that's
okay. Yes. Yeah. You guys got a minute to catch up to me. Yes.
What does this mean?
Okay. Welcome to the text. Oh, wait, you open the CSV file.
Okay.
Right.
So that's what I went to file. Yep.
Open.
Data.
We want to do the Excel version of it.
Right. So.
Excel.
Okay.
Here's Excel. I got that. Okay. And then number 3 we're looking for. Oh, you don't have it here.
Oh, I just
We're looking for file number 3. Oh, you know what happened was you erased it because you didn't turn it into a CSV file. Okay. Download it again. Just download it again. You'll see it.
Right here. It's a copy of 3.
That one?
This one, copy of 3. Okay.
File. Save as.
Okay.
And what happened?
I think it's just.
Oh, there it goes. Okay, well, save it as an Excel file.
Oh, not as a CSV.
Well, yeah, for this purpose. Yeah.
I see, okay.
So normally, if we're your computer, when you change it to a CSV file, it would have kept both.
Okay.
On this one, it just overwrites it. Okay. So, okay. As you're looking at this, take a look at the top of the column where the variable name is.
So when I saved it, I didn't save it as a
Just download it again. Or just open that. Double click that. Say save as. Okay. Save that. Change the Excel workbook. Say save. Say save. That's an Excel workbook again.
Well, then it should open then the way that I had it, because that's exactly what I did. So
Yeah.
wait,
Okay.
so now I'm
Yeah,
here.
go out of the way. Go back and take SPSS.
Wait, go back. Here.
So, okay, yeah, cancel. No, you want to get into SPSS. SPSS is that one. That one.
I think I have a lot of them open.
That's okay.
Okay, so now I'm here. Read
Okay,
variables for me.
that's the X is going to be in the first row. And that's the range of data that it sees also. But we only want A1 through A22. A1 colon A22.
And that's
Yep, that would work. That would, you don't even need that.
I didn't. Oh, I don't think so. See.
Now hang on a second. Keep an eye open. Look up front. Look up front here. Okay, everybody look up, yes.
Can we get to the
A1 through A22. Put in A1 through A22. A1 colon A22. Okay, guys, so you should see something like this. There's a good chance you don't. You may see something like this. How many of you see something like that? Okay, there's a little tab on the bottom here. It says data view. You can't see it from online because because it's too low for you to see on the screen. Data view and variable view. You can also go up here to view, and you'll see. Okay, view is data. Okay, click on data, and view is well. Now that it's data that's described, then if I go back down, it says click here to get to variables. Okay, in the variable view, it's listing all of the variables. We only have one variable, x, right? If I want to see what the data is, I just go into view, and I go back to look at the data. When you have something like that where you click it on and off, that's called a toggle. Okay, so now I'm looking at the data right now. The value, the x, SPSS noticed that there was a letter on top of all of these numbers. There's some text on top of it. So it assumed that that's the variable name you want to give to it. And then it listed all the numbers below it. And indeed, that worked correctly. Now I'm going to go to the variable view. In the variable view, for every variable, every column that you have in your data, you're going to have a row in the variable view that represents it. And in that location, you can do something you can't do in Excel. You can describe to SPSS the specific nature of your data. That's really important, right? Because in statistics, whether it's nominal data or categorical data, nominal data, hair color, you don't want to be able to calculate means and standard deviations with nominal data, even if you represent the numbers 1, 2, like redhead is 1, even the number, if you take an average of those numbers, it really doesn't mean anything. Like male and female, 0 and 1, right? What's the average? The average is a person has one testicle and one breast. Right? Doesn't mean it's meaningless in real life, right? So we don't want to be, we want SPSS to understand what our data is. And if SPSS understands what our data is, it'll keep us from making mistakes. It'll keep us from doing operations that are inappropriate for that data. Okay? And similarly, if we have problems getting it to do something, one of the things we have to do is go back and check to make sure our variable is properly described. Okay, so this is x. In x, there I have the variable name, the variable type. In this case, it's numeric. Maybe it's an age. You want to do descriptive statistics, it's got to be numeric, can't be nominal, right? Okay, when I click in there, notice that a little blue box appears. I can click in that little blue box, and I can tell it what kind of variable type it is. If that's not really the variable type from the perspective of statistical variable. It's just how the data is represented, date, dollar, and so on and so forth. Okay, so I'm just going to leave it as a plain number. The width is how many spaces I want to leave in that variable row for that. I could actually lower that if I want. Decimals, how many decimals that the data is going to contain. Okay, in this case, it's all whole numbers, so 0 decimals. Label. I can put in here a label that is, when you give SPSS, when you give something a variable name, it has to be made up of letters and numbers. Can't have any spaces in it. Can't use certain special characters. Until recently, it couldn't be bigger than a certain number of characters long. So over here, if I know X is actually blood level, I can type in the real label for what X really represents. What that does for me is, anytime I create a table or do a calculation, create a chart, create a graph, it's going to substitute the label for me so that the chart will be ready and able to go somewhere else, copy somewhere else, and be descriptive enough that somebody else reading it will be able to understand what's there. Okay, if I go into the values, okay, values right now says none. If this were a nominal variable, and we had, for instance, eye color, blue, hazel, brown, so on and so forth, if you clicked in here, you could tell SPSS that the number 1 represents hazel eyes. The number 2 represents blue, and so on and so forth. So then you could use numbers to represent the data for each individual rather than type in the data. You don't like typing in data because, for instance, if I typed in blue, capital B-L-U-E, and I typed in blue, lowercase blue, B-L-U-E, as far as the computer is concerned, it's 2 different results, right? So it's better if you define it as a letter or a number, like 1, so that way you just type that in and you can't mess it up. It understands what the data actually represents. So very frequently you summarize nominal data with numbers or letters, and then on the value labels is where you describe what those numbers or labels represent. This, in this section, you just tell it what to do with these missing values. In other words, whether or not to eliminate, if you have a whole row of data, and one piece of data is that one variable is missing, well, SPSS is going to want to know, if I do calculations on this rest of the row, rest of this row of data for this individual. In other words, if his gender is missing, do you want me to include calculations for the average age and for the average and for the genotype and for the number of lymph nodes that are affected and for so on and so? Do you want me to include all that and all the rest of the calculations if the gender is missing? And you can tell it what to do with missing values, and you can code those missing values in here. Columns. Alignment, that's just whether you want it, how you want the data to look. Scale, okay, this is where you identify type of data. Scalar data is numerical data. You know what ordinal data is, and you know what nominal data is. So basically, SPSS gives you 3 choices for the type of data type. Okay, scalar or numerical, ordinal for ordinal data, and nominal for name or data that describes a name. Okay, and for the moment, that you don't have to worry about this other part. Okay, so now I've described my data. I'm going to go back to my data. Okay, there's my data. So now SPSS allows me a very fast, efficient interface for actually using this data now. Okay, so for instance, if I want to analyze this data, I'm going to click Analyze. Now I have one row of data here. Okay, I'm going to go through this. I'm going to say, okay, let's go to descriptive statistics. Okay, I have a bunch of choices in descriptive statistics. I have frequency. I'm going to do that. Frequency isn't really appropriate here, because what does frequency do? It counts how often something occurs, right? This is all different numbers. There may not be 2 numbers in this data set that occur twice, right? So this numerical data, you're really not concerned usually until you get into graphing and accumulating data about frequencies. Frequencies usually are interested in nominal data. In other words, I got 22 people. How many of them are male, how many female? So if this data were gender, I'd be interested in doing frequencies. How many people with blue eyes? 22 people, maybe 12 or something like that, or whatever. Right, so frequency is like a little bit out of the range of what I want to do here. So I'm going to go to descriptives. I'm going to click on descriptives, and as soon as I choose an analysis I want to do, SPSS, the next thing it wants to do is, well, what data do you want to do it on? This is kind of obvious because there's only one variable, but we could have had 12 columns here, 20 columns here, 100 columns here, all with different variables. What do you want to do the descriptive statistics for? Well, I want to do it for this first column for blood lead levels, or X. Notice it filled in the value label that we put in there, right? Okay, so to let it know I want to do it with that one, I just click on there and I move it into the second box, which indicates which statistics I want it to do. Almost all of these are going to have some sort of options and so on and so forth on what statistics or what operations you want to choose. Right now, it's going to calculate the mean. It's going to calculate the standard deviation. Let's tell it to calculate the variance too. Okay, and for right now, I think that's enough. I'll click Continue, and then I'll click OK. SPSS now opens a new window. The data window is still there. It's behind this window, right? I could, minimize this and see it back there. But it created a new window, and it also created a text file which describes the operation that I just did in its syntax language. Just like R, SPSS has a syntax language, a programming language. So you could get this same result by typing in this information right here instead of using the menus. And if you wanted, you could edit this and, you know, and have it do other things that maybe aren't that easy to do through the menus. Okay, so I do my descriptive statistics. It finds that the total number of subjects is 21, 15 is the minimum, 32 is the maximum, means 22.48, standard deviations 5.24, variance is 27.8, whatever, 82. Okay, what do I know about standard deviation and the variance? What's the relationship? One's the square root of standard deviation, square root of the variance. Okay? 5 times 5.2 times 5.2 is 27.4. Okay, so that's very interesting, but there's other statistics I don't see here. Well, in fact, there's another choice that you could have made here. Analyze, so always analyze, descriptive statistics, except this time I'm going to go down to explore. Now I have a few other boxes here. In this case, I'm just going to move this over to just as I was going to do before, and I'm going to say, okay, well, that's enough for now. Just that one variable. I'm not going to worry about these other boxes. I'm going to go in here to statistics, and sure enough, it says, I calculate the descriptive statistics. It's already checked off. There's something here called confidence interval. We're going to be talking about that later on. I'm going to leave that in there. Okay, I'm going to go into plots. And it says it's automatically going to always calculate a box plot and a stem and leaf plot. If I want more, I have to ask for it. For instance, let's do a histogram. Okay, I'm going to check off histogram. Okay, and I'm going to click continue, put down, and then I'm going to go, let's see, and then down here it says, what are the options we got? Oh, these options are what I want to do about missing data and stuff like that. Okay, I'm going to say okay, or I can check off display both statistics and plots, or just statistics or just plots. I'm going to say both. I'm going to click OK, and same data, same selections, basically. It's giving me a lot more information. It's giving me a confidence interval. Again, that's going to come up later. It's going to give me the mean, median, variance, standard deviation, minimum, maximum range, interquartile range, skewness, so on and so forth. It's going to give me a plot of a histogram. Does this data look very normal? Looks skewed to the skewed to the right, skewed to the right. It's got some people that have high values that are away from the bulk of the people. Right, it's positively or skewed to the right. Okay, and here's our stem and leaf plot. Notice that that's very similar to our histogram. And you can actually go in and click into these things. Okay, here's our box plot. What does this bottom feather mean? That's the lowest level. That's the lowest number, which is like 15, 16 or something like that. It's the highest. The highest is like 34 or something like that. Okay, what does this, the bottom of this box represent? 25th percentile, top of the box? Okay, now the tough one. What does this bar across the middle represent? How many of you said mean? If you said mean, you're wrong, right? It's the median, right? Okay, so that's the median. That's the middle value. Okay, 50% of the value is above it, 50% of below it. And notice, if this were normally distributed, where would you expect to see the median? Right in the middle, right? We see the median down towards the bottom, which means that it's skewed, right? Skewed, the mean is pulled away to the top. So it's skewed to the right or positively, just like we saw, if you imagine it's tipped over that way, just like we saw before. Everybody comfortable with that? Okay, we're going to do another example. I'm going to add one more complication to this. A lot of times, we don't just want to work with just one set of data. We want to compare apples and oranges. We want to see the people that eat peanut butter live longer than people that eat jelly, right? And all of them live longer than people that eat peanut butter and jelly, right? Or what did Elvis used to eat? Peanut butter and bananas, right? Peanut butter and bananas, I think was his favorite sandwich, right? Well, we want to see if people that eat peanut butter and bananas live shorter lives than people who eat peanut butter and jelly, right? So we have ages of maybe mortality, ages that people die to rate these different things. So we have two groups. What we've seen here with descriptive, we use descriptive statistics, only works with one group. But we're going to get around that. So we're going to open up another data set here. How are we doing on time? 7:35? Okay, we got a little bit of time left. Okay, I'm going to open up another data set here. I don't want to save this. See, if I said no, it ditched that outlet. If I said, I could have told it not to close that output window, right? And what SPS will do is, as I do calculations, it'll save everything to the same output window. And then I can save that, I can export that later on, and so on. Okay, so I am going to open a new file. I'm going to File, and I'm going to open this file that's on Blackboard called Serum Zinc. Let's see what's in this. No, I don't want this file. I don't want that one. I'm going to say Open Data. I'm going to import another Excel file. I'm going to find, okay, how about lymph nodes? Number 2, lymph nodes. And I'm going to say Open. Now again, this is an Excel file. It's asking me, do you want me to read, and it realizes it's an Excel file. It says, okay, I'm going to import this, but do you want me to read the variable names from the first row of data? You'd have to look at the data to know whether the first row is actual data or just the variable names, right? I happen to know it's a variable name, so I'm leaving that checked. Right? Otherwise, you'd have to actually open it in Excel and actually look at it. Okay, and it says that this worksheet goes from A1 to N63. I'm going to import the whole thing, even though I'm only interested in a little bit of it. Okay, so notice that each one of these columns represents a variable. V1, a G, T, N, M, age and initial diagnosis. 4-year survival, lymph nodes removed. Okay, and I think somewhere in here, do we have gender in here? Gender. Right, here's gender, I think. 2 and 3. Is that gender? Where is it? You see gender? All the way to the right. Oh, grade. But there's gender in here somewhere. I think I saw it. Oh, there it is right there. There's gender right there. Okay, F and M, right? That represents gender. I'm going to go to the variable view. Okay, and in the variable view, let's see gender. Here's gender. Gender is a string variable, 1 wide. It's a number. String is a letter. String variable is a letter or a number. It's 1 wide. It's either an F or an M. And it is encoded, right? Let's see. Values. I'm going to click in here. And I'm going to click down. Now, I'm going to tell it that F represents female. Okay, and I'm going to say add. And I'm going to tell it that M represents male. Oops. Put a caps lock on. Okay, and remember to click add before you go into ifs. Whoops. It's hard to work with this machine. Or sideways. Okay, so from now on, when it sees F, it says that it's going to substitute female. When it sees M, it's going to substitute male, which is much nicer if we're going to print out a chart of data and we want to be able to use it somewhere else rather than lowercase f and lowercase m. I'm going to click OK. And in the absence of a value label for gender, it's just going to default back to gender, the variable name. So we use the variable name. Okay, so now let's say that I want to know what the average number of lymph nodes were removed for females and males. Maybe there's a difference in the number of lymph nodes that are typically removed for females and males, right? So this is the number of lymph nodes that are removed, and this is the gender. So those are the 2 variables that we're interested in. Okay, so gender is a nominal variable. See if I follow this across. I'll see nominal. Let me see. Gender. Let me highlight this. And let me highlight the whole thing. Nominal. And the number of lymph nodes removed is a scalar variable. Just what I want. Okay, so I'm going to go back to my data view. Okay, and I don't have to. I just went back there. I'm going to say Analyze, Descriptive Statistics, and I'm going to go down to Explore. Okay, so now, well, what am I finding the descriptive statistics of? Right? It's not gender, it's lymph nodes, right? So I'm going to move the lymph nodes removed into my dependence list. Now, what are we doing with the factors list? Now, what do I put in there? When you factor something, you're breaking it up into parts. So we're breaking it up into male and female, right? So I'm going to put gender into my good guess back there. I got to put gender into my factor list. Okay, and again, I'm going to go into my statistics, my options here, and the descriptive statistics is turned on. Okay, I'm going to go into my plots, and I'm going to tell it to do histograms again. It's going to do histograms for each group. It's going to do box plots automatically no matter what we say. Say continue. And display both is selected, so I'm going to say OK. And see what happens. Well, now I have descriptive statistics for both of these groups. There were 28 females, 34 males, the frequency, right? Calculated the frequency. The mean number of lymph nodes removed for females was 19. For males was 18.88. They're pretty close, right? And the standard deviation for females is 6.89. And for males is, standard deviation is a little bit bigger, so a little bit more variability with males. Well, let's take a look at the box plots. There's a histogram for females. It's skewed to the right. Here's a histogram for males. Okay, also skewed to the right. There's a few people who have a lot more lymph nodes removed. And here's a box plot. Doesn't look like there's much difference, does there? And as far as the males are concerned, right? Remember we said it was skewed to the right? Well, apparently there are two people, these two guys, subject number 16 and number 17, they got way more lymph nodes removed than the other males in this study. So they're appearing as outliers. So SPSS is going to give you an opportunity now to decide whether or not you want to include that data as part of your calculations, or you want to re-examine it to see why was that true. I mean, was there something going on there that involved removing so many more lymph nodes, something that wasn't relevant to your study. Okay, so that's what our box plot shows. I mean, the medians look almost exactly the same, right? Doesn't look like there's much difference here. Okay, but we can see that now very easily because SPSS allowed us to do descriptive statistics very efficiently, and it allowed us to display it graphically and to summarize it in a form that other people could see it. The last thing I want to mention is that the whole point of doing all this is that eventually you might want to be able to use this stuff, click and copy, edit and copy. Whoops, I didn't get it. Highlight that box, edit and copy. And then you can work with this. You can put this into a report or a paper or whatever. Let's see if I can't get into Word. Microsoft Word. Let's do this. I just want to show you one thing with this. And that is, you got a couple of choices when you paste it into Word. And that, you can actually start to use this stuff for your other courses. You have data gathering in other courses. There's no reason for you not to use this software, Excel, SPSS. Use it usefully in other places because these are tools, you know. And the lab portion is, we're doing two things here. We're learning statistics, and we're also learning how to use valuable tools. So you can actually start to use these tools immediately. Next week, if you have to do a report and you want to put together a histogram, you can use Excel or SPSS to do that for yourself. Okay, now I want to paste this into here. But now, if I just click paste, it's going to use whatever the word default at this moment has to be. There's a lot of choices on how to paste something in. So I'm going to click down here. The little arrow down there. If I click on that, it gives me some other choices like paste special. And if I click on paste special, now I get a selection, a bunch of selection. If this were a table, it would ask me if I wanted to install it as formatted text. It would ask me if I wanted to install it as plain text. It would ask me if I wanted to install it as a bitmap or a picture, right? Well, when I'm working with a picture like the graph, I don't get that many choices. JPEG, bitmap, I'm going to pick JPEG for the moment. It's going to install it as a JPEG. Now, the nice thing about installing something as a picture is when you click on it, it's got little corners that you can grab. And it makes it easy to resize it and move it around. How many of you had the experience that you take something from another program, which is a table, you paste it into Word, and the columns are out in the left field over there, completely off the page, right? That's because it's not formatted for that page. But you could painstakingly go through that and narrow it and reformat it and stuff like that. Or you could just say paste special and paste it in as a picture. If you paste it as a picture, it'll automatically adhere to the margins, and you can resize it and move it around much more easily. The downside of doing that is that if you got to change a number inside the table, you can't because it's a picture, not a table, right? But usually you're at the point where you're pasting it in, you really formatted it and it's ready to go, right? So I find a lot of times you save yourself a lot of grief by going to the paste special, pasting it in.